So we have this report. It gets a lot of data. It takes a bunch of time, almost 3 seconds here. And we can see most of that time is in database queries. So 1.45 seconds and almost 1 second for these two queries alone. And then we have some other queries that are pretty quick, but we'll see if we want to optimize them as well. I had some more information in the debug bar at the end of the last video. I'm just going to show you how to get that back. Right now, this is the default debug bar output, and it's just the queries and their timing. And while it's useful, we can get some more information out of it. So I'll head back to PHP Storm. We'll head to the config, and I'm going to go to the config for debug bar, and I'm going to search for the word explain. And this is going to show explain output on queries, and we can set that to true. And what debug bar is going to do is for each query it detects, it's going to run explain against them if it's a select statement. So I'll show you what that means exactly. Let's head back to our browser, refresh this, and then we'll get the explain version of each query. So for each query, we get an explain comment. We can see that here. It's going to output that same information in a slightly different format here, but we can see the same info. The possible keys as primary, the key that it used, the index that it used as primary. The rows it had to scan was only 1 because there's only one row that matches that, and where the ID is 1. Okay, so there's nothing we need to do to this query also, right? This is basically as good as it's going to get. There's really not much we can do because the where statement here is doing the ID equals 1, and that's already using an index. So I'm not going to worry too much about changing this query at all. And 4 milliseconds is pretty quick. Okay, so that query we talked about. Let's jump down here. So select ID from customers where user ID is 1. This actually took under a millisecond, so this is extremely fast. Now, the interesting part about this is that it's not using any index. There's no index on the user ID column on this table. So let's see, that was the customers table. We'll see table info. It has a primary key on the ID column, but we're using the user ID column in the where part of that query. And even though there's no index on the user ID, it's still a really fast query. Now, mostly that's because it's a small table. There's 1,800 items in it. That's pretty small as far as database tables go. So that's going to be a very quick query unless or until this table blows up in size. So I actually am not going to do anything to this database table yet. I'm not going to add an index to user ID, even though we could. If you are in a situation like this and you're going to see a table like this grow very large, then maybe you want to put an index on it ahead of time. But I'm going to wait on this table and just not do that yet because the gains from adding an index will be very small. In fact, it might be negative because then it has to do extra work to read from the index. This is already under a millisecond, so I'm just not going to worry about that. All right, so let's go to this query right here. Select distinct domain from page views where user ID is 1. So we have two things going on here. The where statement is on the user ID column from the page views table. And we can see the explain, and there's no key on it, right? So there's no index, so it's not using an index. And the rows it needs to scan is all of them, right? 4.6 million rows. So this is a large query. It's the longest running one we have, 1.5 seconds, because it has to scan 4.6 million rows of data to see which have a user ID of 1, and then to do the extra calculation to make sure we only grab distinct domains. In other words, columns named domain that have distinct values. So we see it's using where because it has where user ID is 1, and then it's using a temporary table to help with the calculation of distinct domains. So this is one we want to improve on. Now we could add an index just on user ID to help it, but we can also add an index on the domain column, and adding an index on the domain column improves it even further because then the indexing can be helped to scan through the domains that are user ID of 1 and only give us distinct ones. The indexing helps that as well. So I'm just going to show you how to do that manually, and later at the end of the course we will see how to add indexes in Laravel as well, so you can do it there in code. So I'm just going to paste in a query here. This query is going to create a new index to the page views table, right? Because the page views is where we're selecting from to get the distinct domains. And we're going to add an index. And how I name the indexes here is usually the table. This is actually Laravel's convention that I follow. So the table, the columns, and we just name it an index. And then we tell MySQL what columns to index. And actually the column order matters a little bit. So typically what I will do is start with the stuff in the where section, and then that's almost always all you need to do, just the stuff in the where section. But then since we're adding domain here, also I'm going to add the domain column into that index. Now this isn't part of the where section of the query, but it is technically still doing stuff on the domain here. So we're going to add an index of 2 columns here because it's dealing with 2 things, and we'll just see how that helps us out. So alter table page views, add page views user ID domain index on the columns user ID and domain. So this index is mostly going to be used, it's going to be most effective for queries that involve the user ID and the domain. In other words, filtering on user ID and domain. So let's run that. This is going to take a few seconds because it's running against 4.6 million rows of data. Once it's done, that index will be built. Okay, and finally that finished after 41 seconds. So if we go to table info for page views, we'll see we have a new index, page views, user ID, domain index, user ID, and domain. So now let's actually head back here and see what we have improved, if anything. Okay, great, check this out. 5 milliseconds for this query, under a millisecond still for this query, and now this, instead of being a second and a half, it was only 256 milliseconds, right? So that's like a quarter of a second. So that's really quick. And actually this one went up to 3 seconds. So that one will vary a bunch until we add some indexes in that as well. This one staying around 250 milliseconds, which is great. We have it down to a quarter of a second from a second and a half. Great, so let's see the explanations for that as well. So now the possible keys it might use is the new index we just used. And instead of 4.6 million rows of data, it's checking against, it's filtering against. Now it's only 163, now it's only 1.6 million. So we went down, like a quarter of the number of table rows that it has to scan. And that's because we have about 1.6 million rows of data where the user ID is 1, and then it has to do the extra calculations to make a distinct set of domains from that. So it's still going to scan all of those rows to do the distinct item. But we've made it quicker, right? It's still a lot faster. Now we're actually going to have some unexpected benefits from this because this index has user ID in it. Other tables that use the user ID might actually be affected as well. So notice that this actually went up, right? This was actually more like 1.5 seconds, if I remember right. So let's see what's going on here. This is actually using that index as well, but we've actually made it more complicated, and so the time for this one goes up a little bit. So we're only filtering on user ID here, but the main thing is that it's grouping by date, and then we have a where statement of user ID. And this, because there's an index that has user ID in it, is actually using that index we used. So this again is only filtering against 1.6 million rows instead of 4 million, and it's using this key, this index that we created. So it's using index condition, is using where, using temporary, using file sort. It's actually still doing a lot of work to do the casting of the date and the grouping by of that date field. That date field is a named field based off of a calculation, right? And it's going to use a temporary table to get that, I believe. So this one might be a little slower now because of that. So we're going to see how we can fix that as well. All right, now we haven't done any of the filtering here. So if I go to, I'll just keep last week, I'll filter by a domain. And that was really quick. Look, 3.9 milliseconds. So this is no longer in the seconds range. This is super quick, in fact. And the reason is because it's going to use the exact index that we created for this one. So select distinct domain page views for user ID. We created a key on user ID and domain, and actually now the where statement here is user ID and domain as well. Domain equals Abbott. So it's using this exact key. The number of rows it gets from those two where statements is only 963. So that's all it has to scan through to do the other stuff for the date calculation and grouping by and all that good stuff. So we made this query very quick, accidentally almost, by adding a index for this that this query can also use. Now, if we add some more stuff to it, like say I want customer number 17 with this domain, that looks like it was pretty quick too. I thought that'd be a little slower, but actually it still makes sense that this is quick because even though we have more in the where section here, it's still able to use this index, right? If I go to explain, still using user ID domain index because the where statement still has user ID and the domain. It also has customer ID and created that, but just from the fact that it can use this one index and get the rows down to 963 from that index, then the remaining portion of stuff it has to calculate is just the customer ID and the date stuff, and that's really quick on just that small number of rows. So we've actually improved the condition where we are filtering by domain and the user ID, of course, that's implicit, and the domain and customer, by sheer fact that domain and user ID index is really easy. And let's prove that by saying don't filter by domain, only filter by the user and the customer. Now we're going to go back to a slow query now because it can't use an index because that one index that we have so far involves indexing the domain information, right? We're up to 6 seconds. That's huge. So we have taken care of the distinct domain query, and we saw that there's a bunch of stuff going on with this big query where we have some filtering, right? And the reason is because every time we filter by something here, we are affecting the where section of the query, and we're affecting what fields that it queries on. So we have user ID, which is implicit, that'll be every query, and then we have created at, and we have customer ID, and domain optionally if we set the domain. So anytime we set the domain here, we're going to have a fast query because user ID and domain is an index already, and it can use that index. If we don't have the domain there, then it's not going to use that index, or even if it does use that index, it's not going to save us a lot of time because it still has to do a complicated calculation. So in this case, we have the user ID and the customer, and that didn't save us any time. It's still a lot of time. It's still a huge query in terms of how long it takes to return from the database because of all the calculation it does. So we have a slow base query here where it's just based on time, just the last week. We have a fast query for anything that involves the domain being filtered on, even if it's customer. And then we are back to a slow one if our customer is set and our domain is not. So we have one filtering option here that's quick and the rest are really slow. So we want to see what kind of indexes we can add to improve that for the other filtering options here. So what we're going to do here is add an index on the user ID, of course, because we know user ID is part of every index. And then we're going to add an index on customer. So let's see what that'll look like. I'm going to copy and paste this. Page views, user ID, customer ID, and that'll be user ID, customer ID. And let's go ahead and make that index, and we should see this will still take a little bit of a time, just like the last one did, because it's 4.6 million rows of data to make an index on, and we can see what we've improved. All right, so let's head back over here. I'm going to do none. We're just going to go back to our base query, which is just the user ID. It's just what we're filtering on in addition to the date. That's still a little slow, right? Almost 2 seconds. We'll add the domain. We'll see that that's quick again. And let's see what index it uses. So possible keys, right? We have 2 indexes now, and it's going to say it might want to use one of these 2. It's still using the user ID domain index because we have the user ID and domain in the where part of the query here. So that makes sense. Let's add in customer now. I think it's still going to use the same thing, right? So it's going to still use, well, it's actually using both keys. Great. So now we have a key that has user ID and domain, and we have a key or an index that has user ID and customer ID, and it's using both. And look, the number of rows that has to scan is a single row. That is really because there's not many page views for this customer, but also because it's able to use both indexes, and both indexes combined to make this super quick. Look, under a millisecond, because it's able to combine those 2 indexes in a way that makes the calculation, really as limited to the least number of rows possible to do all the date calculation on and all that good stuff. So that's really quick. And we can get rid of domain. So now it's just user ID and customer. That's quick again, right? 2 milliseconds. We're not in the seconds range anymore. And that's because it's using the page views user ID, customer ID index. And the number of rows it has to filter on is only 852, so that's really good too. So now we're covering most of our bases here. The only thing we have left is that if I get rid of any filtering, it's still a slow query because then it's only user ID and created at. Now we can do something like add an index just on user ID, or we can add an index just on created at, but I still like making multi-column indexes to get really specific with the type of queries we make, because the more specific you can be, the better your index performance will be. But of course, that's a balancing act, because the more indexes you create, the more data your database actually has. So it has to create those indexes and store them somewhere. And MySQL tries to store indexes in RAM. So the amount of stuff MySQL is trying to fit into RAM increases with the number of indexes you make. So it's really a balancing act. You don't want to go overboard with making indexes on everything, because the more you do, the more available RAM you're going to need to have for your database to keep all of that in memory. Okay, so again, we have a long query for just user ID and created at. So what we're going to do is make an index on this. And I think this will improve other queries as well, because all of them have created that as in addition to the user ID in it. So let's head back over here. I'm going to copy and paste this, add page views for user ID and created at. So that's the name of our index. It's going to be user ID and created at. And just in case you're wondering, you can make an index on a timestamp field, and that's encouraged in many cases. By default, Laravel does not do that. So you might want to add indexes on the created at row that you create implicitly on those tables that have timestamps within your Laravel scheme builder. Oftentimes that's easily overlooked, since in the schema builder we just say, use timestamps, and it makes those 2 columns, and we don't even think about indexing them. But indexing them can really improve your performance as well. All right, so it took about 30 seconds to make that. We see table info. Now we have 3 indexes, right? User ID created at, user ID customer ID, user ID domain. Let's see what we get. Head back over here. We'll keep our basic query with no domain and no customer. Refresh the page. The whole thing is back in under a second. We have 22 milliseconds for this query. That was 1.5 seconds before. 22 milliseconds, super quick. And that's it. I think we have all the things covered. So last week, we can do by domain. That's quick again, 17 milliseconds. We can add customer in there. That's 1.4 milliseconds. That's the quickest because it has those 2 indexes that it's using. We can get rid of domain. And now we just have user ID created at and customer getting filtered on, and that's 3.8 milliseconds. So that's also super quick. Great. We're really good in this query. Now this guy, the last thing I'm going to say is that this thing is faster than it was before, right? Because this is about 1/4 second and it was like 1.5 seconds or 2.5 seconds originally. We can still possibly do a little better. Originally, I made this index on user ID and domain. I'm actually going to try to switch this up. So I'm going to drop this index and just tweak it slightly. So what we're going to do is alter table page views. I have to spell that right. We're going to drop index, and we're going to drop this specific index. Let's go ahead and run that. And we're going to copy and paste this index, and we're going to call this one, instead of user ID domain, I'm just going to switch it to domain user ID, and we'll switch the order here as well. Domain user ID, and let's create this index instead of this one up here. So all we did here is switch the order of the columns in the index, and we're going to see that this actually is going to make a difference. All right, so this one took about 46 seconds to complete. Let's check out table info, and we'll see we have user ID, customer ID, and domain user ID instead of user ID domain. So the new key is down here. Okay, let's refresh this. That's quicker, a lot quicker. Instead of 1/4 second, that takes 28 milliseconds. So instead of 250, it's 28. That's big savings. And all we did is switch the order of that index. And we can play with these. We can see that these are still quick as well. Let's do none, none. This will probably be the largest one, 23 milliseconds. Still good timing. So all we did was switch that a little bit and it worked. Now this one, this query with user ID and created at, that is using the user ID created at, great. Let's add domain. And now we can see it's using the index page view domain user ID. So it's still able to use this, right? Even though the order of the columns has changed, because this is still going by user ID, it's still able to use the index that has user ID in it, right? It's able to use any of the indexes because all of them have user ID in it. And it just selected the domain user ID one because the query planner in MySQL decided to do that. And it's still quick. And it doesn't matter that the user ID is the second one here. That's still quick. And what we gained from that is that this distinct domains from page views one is a lot quicker now as well. So now we can see we have a page view. The page returns very quickly. The number of seconds in the database is down to below a second, right? 300 milliseconds, where we were at like 2 to 3 seconds before originally. We've saved a lot of time per request. Now, this is at the expense of the database a bit. We have 3 new indexes here. That increases the total size of the database table because it has indexes. That increases the amount of RAM that the database uses a bit because it tries to save all the index data in memory. So that's definitely a bit of a balancing act, and that's why generally in the course, in the full scaling Laravel course, I'll be recommending that you move your database out to its own server with plenty of resources on it. But we can see how well we are able to improve the performance of this page, which has this complex set of queries that change often, just by adding a few indexes and playing to see what works the best. So we'll expand on this a little bit more by adding some caching in another video, but I think this is a good place to stop. I've taken a bunch of time to talk about this topic because it's really important to know that you can use this explain statement for MySQL queries to see what indexes, and what it's called keys, is being used and how it's deciding and how many rows that narrows your query down to. And you can make informed decisions on what indexes to use and what to create based on that. Now, the last thing I want to show you is here in PHP Storm. Let's go to database section, migrations. We can see I have a few here. These are just for the tables though. None of these are for making indexes. So what I'm going to do is just fast forward in time in my Git history, and I'll show you creating the indexes in the migrations. So we'll see our indexes here, and let's just make this bigger so we can see everything. So we are affecting the table page views. We get a table object, and then we can just add indexes with the index function. So during the video, we started with the user ID domain multi-column index, but we eventually dropped that. So I'm just going to have this here as a note, but we dropped it eventually, and we replaced it with this one, which is just a different order of columns. Now notice we have an array here, and we're just feeding it column names, and this will create in Laravel our multi-column indexes. And then we also made the user ID customer ID ones so that we can filter by customer ID more efficiently. And then we also finally created the user ID created at one so that we have an index that uses created at, because created at was in the where column all along as well. And you could play around with this more than even I did for this video. You might want to see if you want to add created at to all of these, because user ID and created at are in all of them. But I think it's going to be able to use user ID created at for all of these queries anyway, in addition to the other indexes if the MySQL Query Planner decides it efficiently can do so. But play around with that yourself. I definitely suggest you add indexes and play with indexes, and don't just kind of blindly say, oh yeah, I'm going to use some specific column to index on, when you could definitely benefit from having multi-column indexes instead.